5 assembled boards arrived and all 5 were defective. 3 were dead on arrival. No power, no USB, nothing. Both test points read 0 volts, while a working board from the same batch read 5 volts and 3.3 on the same cable. Input power was not reaching the rail. The other 2 powered up fine, but could not drive their display because pins on the display header were electrically open. We proved that with a meter rather than a guess. The firmware drives each display signal to a steady logic high, and then you probe the pin. A sound joint reads 3.3 volts. An open joint reads 0. Board A read open on pins 4 and 7. Board B read open on pins 4, 5, 6, and 7. Sit with that result for a second. Same design, same firmware, same cable, and a different set of pins open on each board. A design fault fails identically on every unit. Failures that move around from board to board are process variation. So we blamed the assembly house, and for a while that was the whole story. Here is what nagged. Every single failure was on a through-hole part. 3 pin headers and a USB connector. Meanwhile, 31 surface mount components on the same boards, reflowed in the same oven, were perfect. An inconsistent process scatters its failures. Ours were perfectly correlated with one attribute, and that is not luck. A through-hole joint is not solder sitting on top of a pad. It is solder wicking the full length of a plated barrel and forming a fillet on both sides of the board. To form that fillet, there has to be a pad on the solder side for the solder to wet. Take that pad away, and a barrel that does not completely fill reads open, while the connector still looks perfectly placed from the top. So we opened the bottom copper layer and counted. The pads were not there. Every through-hole pad whose net routed only on the top layer had no copper at all on the solder side. The cause was a single flag in the board file that nobody set. KiCad's own footprint ship with remove unused layers turned off. But the library in our generation pipeline checks whether that token exists and never looks at its value. The file said no. The parser heard yes, and KiCad dutifully deleted the pad. Every gate we had was green. The design rule check passed because removing unused layers is legal. The electrical rule check passed. The Gerbers were valid. The 3D render looked perfect because it renders from the top. The assembled board looked perfect, too. The fix is one line of intent. Set the flag explicitly instead of trusting whatever came back from the parser. 10 pads got their solder side copper back, 3 of them on the connector whose pins measured open. If you generate KiCad files programmatically, open your bottom copper layer in any Gerber viewer and look at your through-hole connectors. Every pin should sit inside an annular ring. Bare holes mean you have this problem too. It takes 2 minutes, and it would have saved us the entire episode.